Malvis. In today's video, we are going to be talking about coordinate geometry. So let's look at examples of how to find the distance between two points. So we are told to find the distance between the following pairs of points. A into 3, 2 and B into 4, 6. Okay, so the first thing to do, don't forget that coordinates is represented by A into x, y and B into x, y. And since we have x1, y1, x2, y2, we need to represent that here. So from A into 3, 2, we are going to have x1 to be 3 and our y1 to be 2. Then here we are going to have our x2 to be 4 and our y2 to be 6. So to find the distance between A and B, we have square root of, we can say x2 minus x1 all squared plus y2 minus y1 all squared. So what is our x2? That is 4 minus what is our x1? That is 3 plus y2 6 y1 that is 2. Then we have 4 minus 3, that is 1 squared plus 6 minus 2, that is 4 squared. So this is 1 squared gives us 1, 4 squared gives us 16. And so this is square root of 17. 1 plus 16 gives us 17. So the distance between points A and B given these coordinates is 17 units. Let's look at example 2, C into minus 1, 3 and D into 2, minus 7. So distance CD equals square root of x2 minus x1 all squared plus y2 minus y1 all squared. So from the coordinates given, our x1 is minus 1, our y1 is 3, then our x2 is 2, and our y2 is minus 7. So we substitute these values in this equation. So x2, that is 2, minus x1 as minus 1 squared plus y2, that is minus 7, minus y1, that is 3 squared. So what do we have here? 2 minus times minus plus, that is plus 1 all squared plus minus 7 minus 3, that is minus 10 all squared. So we have 2 plus 1, that is 3 squared, and we have minus 10 squared. Of course, minus 10 squared is just like minus 10 multiplied by minus 10. Minus times minus, that is plus, 10 times 10, that is 100. So this is what? 100. So we have 3 squared, that is 3 times 3, that is 9 plus 100. We have 109 units. So the distance between point C and D with the given coordinates is root 109 units. Are we set? Alright, so let's attempt this question. We have to find the distance between each pair of points. Number 1, P into 7, 2 and Q into 1, 6. Don't forget, these are the coordinates of P and Q respectively. So, solution. Number 1, P into 7, 2 and q into 1 comma 6. Our x1 is 7, y1 is 2, x2 is 1, y2 is 6. Then our pq will be square root of x2 minus x1 all squared plus y2 minus y1 all squared. So substituting our values, we have x2, that is 1 minus x1, 7 all squared plus y2, 6 minus y1, 2 all squared. So 1 minus 7, we have minus 6 all squared plus 6 minus 2, we have 4 all squared. Minus 6 all squared, that is 36 plus 4 squared, that is 16. So 6 plus 6, you have 12, you keep 1. 1 plus 3, you have 4 plus 1, that is 5. So square root of 52 units is the distance between P and Q. So question number 2, we have m into 3 comma minus 3 and n into minus 2 comma 5. So we have x1 to be 3, y1 to be minus 3, x2 to be minus 2, and y2 to be 5. So distance mn, square root of x2 minus x1 all squared plus y2 minus y1 all squared. So our x2 is what? Minus 2. Our x1, 3 all squared, square root here. Then y2 is what? 5. And our y1 is minus 3. So we have minus 2 minus 3, that is minus 5 all squared. And this is 5 minus minus 3. Minus times minus, that is plus. 5 plus 3, that is 8 squared. So minus 5 squared is what? 25. That is minus 5 multiplied by minus 5. Minus times minus plus 5 times 5, 25. So this is 25 plus 8 squared, that is 64. 25 plus 64, say 4 plus 5, that is 9. Then 2 plus 6, that is 8. 89 units. Depending on the kind of question or the options given to you, you can decide to simplify this further. You can find the square root of 89 and get decimal, or you can decide to leave it this way. Thank you. So the next thing we are going to look at is the gradient of a straight line. How to find the gradient of a straight line. Let's say this is x-axis and this is the y-axis. Now another word for gradient is slope. S-L-O-P-E. And it is often designated with M, letter M. Now, what do we call slope on a straight line graph? It is change in y-axis over change in x-axis, or increase in y-axis over increase in x-axis. So, since tracing this downward will give us x2, and tracing this downward is x1, then tracing this here is y1, tracing this here is y2. Then increase on y-axis will be what? y2 minus y1. And increase on x-axis will be what? x2 minus x1. So the formula for slope is y2 minus y1 over x2 minus x1. So we're going to use this to solve some problems. Let's say we have coordinates 3, 2 and 4, 6, and we're asked to find the gradient. So this is what our x1, this is our y1, this is our x2, and this is our y2. So slope or gradient equals y2 minus y1 all over x2 minus x1. So all we need to do is substitute our values. Y2, that is 6, minus y1, that is 2, all over x2, that is 4, minus x1, that is 3. 6 minus 2, that is 4. 4 minus 3, that is 1. Therefore, our slope equals 4. So this is how to calculate the slope of a straight line. This is B, this is alpha. P what? QR. P, QR, okay. Okay, so we want to look at how to find the angle of slope. Angle of slope. Now that we know that our slope is changing y over changing x, that is q over r, qr over pr, that is our slope. To find this angle will become what? If you study this PQR, this is a right angle triangle. QR is opposite to angle alpha. PR is adjacent to angle alpha, while PQ is hypotenuse to angle alpha. And if you remember from your trigonometric identity that tan equals opposite over adjacent. Therefore, we can say tan alpha equals QR over PR, which is also equals to M, that is the slope. So to find the angle of slope, we are going to have tan alpha equals to slope. Alpha equals to tan inverse of whatever the value of your slope is. So let's solve some question and see how to apply this formula. Find the gradient of the line joining (3, 2) and 7, 10. Then B, -3, -5 and 4, -1. Then find the angle of slope. So to solve the first one, we have 3, 2 and 7, 10. This is our x1, this is our y1, this is our x2, and this is our y2. And our slope equals y2 minus y1 over x2 minus x1. y2 is what? 10 minus y1, 2, x2, 7 minus x1, 3. So this is 10 minus 2, we have 8. 7 minus 3, we have 4. 8 divided by 4, we have 2. So this is our slope. So to find the angle of this slope, we say tan alpha equals to 2. And alpha equals tan inverse of 2. And alpha equals 63.43 degrees. So the second question, we have minus 3, minus 5 and 4, minus 1. So our x1 is this is our y1, this is our x2, and this is our y2. So slope is y2 minus y1 over x2 minus x1. We have minus 1 minus 5 all over x2, 4 minus 3. So we have minus 1, minus times minus, that is plus, all over minus times minus, that is plus, 4 plus 3. Minus 1 plus 5, that is 4. 4 plus 3, that is 7. So 4 divided by 7, we have 0.5714. 5714. And this is our slope. Then the angle of slope is tan alpha equals 0.5714. Then our alpha will be tan inverse of 0.5714. So for those of us that don't know how to calculate this on our calculator, you can simply press shift tan. For other calculators, you can use second function then tan. But most of the calculators we now have, you see shift tan 0.5714 will give you 29.74. So our alpha is 29.74 degrees. So if you are asked to round up your answer to the nearest degree, that would be 30 degrees. 30 degrees. So that is how to find the angle of slope.
The midpoint of a line segment. Finding the midpoint of a line segment. So we have a question here. Find the midpoint of the lines joining the following pairs of points. So let's start with the first question. Now, the midpoint of the straight line joining 2 points, all right, is given as x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So anytime you are required to find the midpoint, all right, this is what you use. So let's attempt the first question. We have a into 3, 5 and b into 1, 3. So our x1 is 3, our y1 is 5, our x2 is 1, and our y2 is 3. So using this formula, we have x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Our x1 is 3, so you say 3 plus x2, that is 1, divided by 2, comma, y1, our y1 is 5, plus y2, 3, divided by 2. So 3 plus 1, that is 4, divided by 2, comma, 5 plus 3, that is 8, divided by 2. So 4 divided by 2 gives us 8, and 8 divided by 2 gives us 4. So this is the midpoint of the line joining A and B. So let's see the second question. We have P into minus 1, comma 7 and Q into minus 3, comma minus 5. So this is our x1, this is our y1, this is our x2, and this is our y2. So x1 plus x2 will now be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So minus 1 plus minus 3, that's minus 4 divided by 2, comma, 7 plus minus 5, that's 7 minus 5. That is 2 divided by 2. Alright, minus 4 divided by 2, that is minus 2. 2 divided by 2, that is 1. So minus 2, comma 1 is the midpoint of the line joining P and Q. So the third question, we have C. That is E into 0, comma, E into P, comma 0, P, comma 0, and F into 0, comma Q. So this is our x1, this is our y1, this is our x2, and this is our y2. So x1 plus x2 will now be P plus 0 divided by 2, comma, y1 plus y2, that will be 0 plus q divided by 2. So P plus 0, that is P over 2, 0 plus q, that is q over 2. So this is the midpoint of the line joining E and F. So there are times that you'll be required to determine if a line segment, alright, is parallel to another line or if it is perpendicular, if a straight line is parallel or perpendicular to another. So this question says determine if line AB is parallel or perpendicular to line PQ in each of the following. So the first thing I want to do is give you condition for parallelism. Now for two lines to be parallel to each other, alright, M2 must be equal to M1. That is, the slope of one line must be equal to the slope of another. Then condition for perpendicularity. For two lines to be perpendicular to each other, the product of the two slopes must be equal to minus 1. That is, M2 is equals to minus 1 over M1, or M1 equals to minus 1 over M2. So these are the conditions for parallelism and perpendicularity. Once the slope of one is equal to another, it is parallel, or they are parallel rather. But once the slope, the product of their slopes, give us -1, then the two lines are said to be perpendicular. So let's solve these questions before us. Solution. Alright, so the first one, we need to find the slope of AB. Let's call it M1. And how do we find slope? In the previous class, I already said that finding slope, we have y2 minus y1 over x2 minus x1. So we need to locate what is our y1, our y2, our x2, and our x1. All right. So from this question, our y2 is 3 and y1 is 1. Our x2 is 4 and our x1 is 3. 3 minus 1 we have 2. 4 minus 3 we have 1. So the first slope is 1. So the slope of AB for question 1 is 2. Then M2, that's slope of PQ. You need to find the slope of PQ. So we use the same formula, y2 minus y1 over x2 minus x1. y2 is 8, y1 is 6, x2 is 5, and x1 is 4. 8 minus 6 is 2, 5 minus 4 is 1. So we can see that m1 is equals to m2. Therefore, we can conclude that line AB is parallel to line PQ. So this is how to go about this question. Then question number 2. We need to find the slope of the first line given to us, all right? And the first line given to us is AB, 4, 7, 6, 8. So our y2 will be 8 minus 7, that's y1, over x2 minus x1 will be 6 minus 4. 8 minus 7 is 1, 6 minus 4 is 2. So let's find the slope of the second line, that's PQ, and compare. So for PQ, we have 6 minus 5 over 5 minus 3. 6 minus 5 is 1, 5 minus 3 is 2. So we can see that M1 is equals to M2. So AB is parallel to PQ. Let's move to the third question. We need to find the two slopes. So for AB, our M1 will be y2 minus y1 over x2 minus x1. All right. So here, we notice we have -1, -2, 2, then -3. So our y2 is -3 minus -2, that's y2 minus y1. Then x2 minus x1 is 2 minus -1. So -2 minus -3 minus -2 is -3 plus 2. -3 plus 2, because minus times minus is plus. Then 2 minus -1 is 2 plus 1. So -3 plus 2 is -1. 2 plus 1 is 3. So the slope of AB is -1 over 3. Let's find the slope of PQ. That is y2 minus y1 over x2 minus x1. So our y2 is 7, our y1 is 4, our x2 is 6, and our x1 is 5. 7 minus 4 we have 3, 6 minus 5 we have 1. So the slope here is 3. So looking at this, they are not the same, all right? So let's test if m1 times m2 will give us -1. m1 is -1 over 3 and m2 is 3. 3 here 1, 3 here 1. So the answer is -1. Therefore, we can conclude that line AB is perpendicular to line PQ. Okay, let's proceed to finding the equation of a line. The equation of a line. The general form of the equation of a line is known as y equals mx plus c, all right, where m is the slope or gradient and c is intercept on y-axis. All right, so y equals to mx plus c is the general form of the equation of a line. But there are times that we will be required to find the equation of a line and we don't know our c. Okay, so they will give us gradient and 1 point form. So in that case, what do? You use y minus y1 equals m into x minus x1. You use this when there is what? Gradient and 1 point form. Then there are times they will give you 2 points, like point A, then give you the coordinate, and also point B and give you the coordinate. What do you do in this case? You simply say y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. So this is what you use when 2 points are given. So that is gradient and 2 point form. Let's find solution to the following examples together. We are told to determine the equation of the following lines. That's question 1. Determine the equation of the following lines. Given gradient is 3, intercept is 2. Then B, gradient is minus 2, intercept is 3. Okay, so to attempt the first one, we have this for question 1A. Gradient, that is m, is 3, intercept c is 2. And you know that the equation of a line is y equals mx plus c. So you just do direct substitution. Y equals 3x plus 2. And that is that about that. Then B, m equals minus 2, c equals 3. So you have y equals minus 2x plus 3. And that is that about question 1. So question 2. We are told to state which of the following pairs of lines are parallel or perpendicular. Okay, before we can tell whether they are parallel or perpendicular, we need to compare their slopes. So for y equals x plus 5 and y equals minus x plus 5, we need to get their slopes in order to check. Now, how do we get the slope? You need to compare each of these lines with y equals mx plus c. So once they are in this form, it will be easy for you to get the slope. So for this one now, if mx is equals to x, it shows that m equals to 1. So I can say my m1 is 1. Then for this one, my m2 is minus 1. So if m1 is 1 and m2 is minus 1, it shows that these two lines are perpendicular. So for the first question in number 2, the two lines are perpendicular. Then we move to B. We have y equals minus 3x plus 2 and we have y plus 3x equals to 7. So here my m1 is minus 3, then y equals, if I take my 3 to this side, I have minus 3x plus 7. So my m2 is also minus 3. So m1 is equals to m2. So these two lines are parallel. The first one is perpendicular, the second is parallel. Then the third, we have 2y equals x plus 3. So for me to get it to the form of y equals mx plus c, I divide through by 2. so that y will be equals to half x plus 3 over 2. All right, and in this state my m1, in this state my m1 is equals to half. All right, then for the second line we have y minus x over 2 equals to 4, then y equals x over 2 plus 4, then here y equals half. So for the first line m1 equals half, and for the second one m2 also equals half. So I can conclude that they are parallel. So the only perpendicular one we have is the first one. So let's attend to example 3. Find the equation of the line of slope 2 passing through point 3, 2. So we have solution. Now we're given this coordinate 3, 2, and that signifies our x1 to be 3 and our y1 to be minus 2. 3, minus 2 rather. And I told you that anytime you are given slope, and they give us slope of 2, anytime you are given slope and 1 point form, the equation of the line becomes y minus y1 equals m, the slope, into x minus x1. So you have y minus, what is y1? That is minus 2 equals slope 2 into x minus, what's our x1? 3. So y minus minus 2 is y plus 2, which is equals to 2x minus 6. All right. So what do we do here? We are going to have y equals 2x minus 6 minus 2. So y equals 2x minus 8. And this is the equation that is required. That is the equation of the line with slope 2 passing through the line 3, minus 2. Passing through the point 3, minus 2. So example 4, we have find the equation of the line passing through point P into 2, minus 3 and Q into minus 4, 2. All right, so this is 2-point form. This is 2-point form, and this is question 3, and we have question 4. I told you that when you are dealing with 2-point form, your y minus y1 over x minus x1 will be equals to y2 minus y1 over x2 minus x1. So in the question we're given p into 2, minus 3 and q into minus 4, 2. So this is x1, this is y1, this is x2, and this is y2. So let's do direct substitution. So y minus y1, since y1 is negative 3, this will be y plus 3 all over x minus x1, that is x minus 2. Then we have y2 minus y1, that will be y plus 3 over x2 minus s1, that is minus 4 minus 2. All right. So here we have y plus 3 over x minus 2 equals 2 plus 3, that is 5 over minus 6. So what do? We can cross multiply. You have minus 6 into y plus 3 equals 5 into x minus 2. All right. So if we open this bracket, we have minus 6y minus 18 equals 5x minus 10. All right. So this is minus 6y minus 5x equals minus 10 plus 18. Minus 6y minus 5x equals minus 10 plus 18, that is 8. That's plus 8. So let's divide through by minus 1 in order to eliminate this negative sign we have here. So we have 6y plus 5x equals to minus 8. Alright. So y, 6y is equals to minus 5x minus 8. Alright. So y will be equals to minus 5 over 6x minus 8 over 6. So we can simplify this further. It will be y equals minus 5 over 6x minus 2 in 8, 4, and 2 in 6, 3. So this is the equation of the line that is required. So here is another question for us. Find the equation of the straight line which passes through the point minus 3, 5 and is perpendicular to the line 2x minus 4y plus 3 equals to 0. Alright, you already know the equation we are going to use. But then something is going to be missing in that equation. You know, the equation is y minus y1 equals m into x minus x1. So the missing factor is m, which is the slope. Alright. So how do we tackle this problem? Let the gradient of the required line be m2 and let the gradient of the given line be m1. Alright, so I'm going to rewrite 2x minus 4y plus 3 equals to 0 in the form of y equals mx plus c, so that I'll be able to get our slope. So 4y equals minus 2x minus 3. Alright, and y equals half x minus 3 over 4. Now, if y equals half x minus 3 over 4, I can say that my m1 is half. So the slope of the given line is half. And we're told that they are perpendicular to each other. And you know that m1, m2 equals to minus 1. That is, m2 equals to minus 1 over m1. Therefore, I can say that my m2 is minus 2. So if m2 is minus 2, it shows that that is the slope of the required equation. So we'll now come back to y minus y1 equals m2 into x minus x1. Now we are given two coordinates, minus 3, 5. So this is x1 and this is y1. So y minus y1 equals to minus 2 into x minus x1. That will be 3. So y minus 5 equals minus 2x minus 6. Alright. So this is y equals minus 2x minus 6 plus 5. So y equals minus 2x minus 6 plus 5 is minus 1. Okay. So y plus 2x plus 1 equals to 0. This is the equation required. Alright, we have find the equation of the straight line which passes through the points minus 3, 5 and is parallel to 3y minus 5x plus 2. So this is just like what we just did. So you are going to make 3y minus 5x plus 2 and rewrite it in form of y equals mx plus c. By so doing, we have 3y equals 5x minus 2 and y equals 5 over 3x minus 2 over 3. Therefore, we can say m1 equals to 5 over 3. Now, since they are parallel, the condition given is parallel, so we have m1 equals to m2 equals to 5 over 3, all right? And the coordinates given, we are given minus 3, 5. So this is x1, this is y1. So what formula do we use to find the equation? That is y minus y1 equals to m into x minus x1. So this is y minus 5 equals to m, that's 5 over 3 into x minus x1, that's plus 3. Alright, so this is 3y minus 15 equals 5x plus 15. So I can have 3y equals 5x plus 15 plus 15. 3y equals 5x plus 30. If we divide through by 3, we have y equals 5 over 3x plus 10. And this is the required equation. So here, we are told to find the equation of the line at the point 4, 3 perpendicular to y plus 2x equals to 5. So we need to find the slope of this line first. So that will be y equals minus 2x plus 5. If you compare this with y equals mx plus c, you bear with me that slope equals to minus 2. And since they told us that the line we are to find is perpendicular to this one, it shows that m1, m2 equals to minus 2, alright? So our m2 will be minus 2 divided by m1, m2 equals to minus 1. Yeah, that's the condition for perpendicularity. m1 times m2 equals to minus 1. So m2 will be what? Minus 1 over m1. And m1 is minus 2. So it shows that our m2 is half. So if m2 is half, our formula is y minus y1 equals m into x minus x1. The coordinates given to us, we have 4, 3. So this is x1, this is y1. So y minus y1 will be y minus 3. Then our slope is half. X minus x1 will be x minus 4. Alright. So if I cross multiply, this will be 2y minus 6 equals x minus 4. So this is 2y equals x minus 4 plus 6. 2y equals minus 4 plus 6, that is plus 2. So I can say 2y minus x is equals to 2. And this is the required equation. So here is a very interesting question. PQ and RS are two parallel lines. If the coordinates of PQRS are 1, Q, 3, 2, 3, 4, 5, 2Q, respectively, find the value of Q. Okay, since P and Q are said to be parallel, alright, it follows that the gradient of Q, of PQ, must be equal to the gradient of RS. So let slope of PQ be M1 and slope of RS be M2. Okay, so to find PQ, let's find the slope of PQ. That's y2 minus y1 over x2 minus x1. The coordinates we have 1, Q, and we have 3, 2. So this is x1, this is y1, this is x2, this is y2. Alright, so our slope will be 2, q over 3 minus 1. So this is 2, q over 2. Then for the second one, m2, That will be the slope of RS. So that is y2 minus y1 over x2 minus x1. What are the coordinates we have? R, we have 3, 4, and S, we have 5, 2q. So this is x1, y1, x2, y2. So by direct substitution, we have m2 equals to y2 minus y1 over x2 minus x1. So this is 2q minus 4 over 2. Alright, so since m1 is equals to m2, let's equate them. So we have 2 minus q over 2 equals to 2q minus 4 over 2. So we can cross multiply. 2 into 2 minus q equals to 2 into 2q minus 4. Don't forget what they ask us to find. They ask us to find the value of q. So divide both sides by 2. You have 2 minus q equals 2q minus 4. So here you can have 2 plus 4 equals 2q plus q. This is 6 equals 3q. Divide both sides by 3. Q is 2. So the required value of q for this question is 2. If the lines 3y equals 4x minus 1 and qy equals x plus 3 are parallel to each other, the value of q is... Okay, for two lines to be parallel, we know that their slope must be the same. So let's take care of 3y equals 4x minus 1 first. We'll need to write it in form of y equals mx plus c. So this is y equals 4 over 3x minus 1 over 3. So by comparison, I know that my slope here is 4 over 3. So let's deal with the second one. Qy equals x plus 3. So I can say y equals x over q plus 3 over q. So my slope here is 1 over q. So since they are parallel, m1 should be equal to what? m2. So we can simply say 4 over 3 is equals to 1 over q. By cross multiplication, you have 4q equals 3 times 1, that is 3. Q equals 3 over 4. And this is the required value of q.